Hi viewers, hope you are all doing well. As our exams are fast approaching, we will see questions a part in the first unit, Unit 1, Matter in our surroundings. Which of the following are matter? We may be knowing what is the definition of matter, that is which occupies space and which has mass will be coming under matter. If the following things, chair, air, love, smell, hate, almonds, thought, cold drinks, smell of perfume. In this, chair will occupy space, air also occupies space. We have seen that examples, balloon, inflated balloon or inflated tires, and almond is a nut and it has self weight and occupies space. Then cool drinks will be having space. So these four things will be coming under matter. The rest of the thing, love, smell, hate, thought, cold and smell will not coming under matter, as it will not be occupying any space and it will not be having any own self weight. Then second question, give reason for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go closer to that. Why? What is the reason? As the particle of hot food have more kinetic energy. What does it mean by kinetic energy? Moving. Particles will be moving, that is known as kinetic energy. Moving from place to place, that has some energy, that is known as kinetic energy. For example, when in the boiling water we can see bubbles are coming up, it shows in the boiling state, on the hot state, particles are moving one place to another. So more movement will be there in the hot state. So as the particles of hot food have more kinetic energy, the rate of diffusion is more. Diffusion in the sense movement from one place to another, spreading. Hence the rate of diffusion is more than the particles of cold food. So we can smell the hot food from the several meters away. Then third question, a diver is able to cut through water in swimming pool. Which property of matter does this observation shows? That means a man can pass through a water, but it is not possible to pass through a stone, table, bench or any solid thing. What does it shows in the sense? The particle of water have intermolecular space, has less force of attraction. Whether it is gas, liquid or solid, particles will be there. But in solid state, particles will be closer, and liquid will be compared to this less closer, and gaseous state very random state. So the particles of water have intermolecular space, has less force of attraction, so we can able to pass through a water, but it is not possible for us to pass through a solid thing. Only the karate person can be able to break a breaker. Okay, then what are the characteristics of particles of matter? Characteristics of particles of matter: particles have intermolecular space. If you assume these are molecules, these have some space between this. So particles have intermolecular space. Then particles have intermolecular force of attraction. It may be repel or attracting with each other. Intermolecular force between the particles. Then particles of matter are moving continuously from one place to another. It will be moving continuously. These three properties are characteristics of particle in a matter. Then comment upon the following: rigidity, compressibility, fluidity, filling a gas container and kinetic energy. What is rigidity? The tendency of substance to retain their shape, maintain their shape. If we are hammering, that means if we are tapping on a table or a bench, it will not lose its shape. So that known as rigidity. Solids are rigid in state. Okay. The tendency of substance to retain or maintain their shape when subjected to outside force. When we are hitting with a normal force, the bench or table will not break into pieces. That is known as rigidity. Then compressibility. The matter has intermolecular space. Okay, whatever the thing, whether it is gas, gaseous matter, liquid or solid, the molecules, the things are made up of molecules, and that molecules will have some space between them. The matter has intermolecular space. When the external force applied on that bring these particles closer together, so that reduces in its size. For example, we can say sponge. Sponge will reduce in its size to become a smaller one when we are pressing on that. So this property known as compressibility. Then fluidity. Fluidity, the tendency of a particle to flow is called fluidity. For example, liquid, waterfalls. Water flow from upper state to the lower state. So this is known as flow. This is known as fluidity. Liquids and gases can flow from one place to another. Wind blows, isn't it? Wind blows. When we are sitting below the air conditioner, we can feel cool air passes over us. It shows cool air forces on us, cool air spreads on us. So the tendency of a particle flow is called fluidity. Liquids and gases gases will flow from one place to another. Then filling of a gas container. What does it mean by filling of a gas container? Gases have, when we have a container, if we fill it up with a small quantity of air, gas also, it will be spread throughout the container. How is it possible? Gases have particles which vibrate randomly in all directions. So even a small quantity of gas can fill the container, spread throughout the container. Understood? Then kinetic energy. What is kinetic energy? The matter requires some energy to move from place to place. That energy possessed by a matter to move from place to place is known as kinetic energy. The energy possessed by a particle due to their motion is called kinetic energy. Understood? Then give reasons. A gas fills completely the vessel in which it is kept. We have seen in the last question, as the gas particle, even a small quantity of gas filled, when we are starting to blow a balloon, that throughout the balloon it started to inflate. Even small quantity of air will inflate a whole balloon. So it shows that particles of molecules of gas will move randomly throughout the container in all directions. Hence, fill the vessel completely in which they are kept. Understood? Then a gas exerts pressure on the wall of the container. It will be spreading, that it will be exert pressure. If container contains gas, it will be we can feel when the air pillow or nowadays even bed is available. If we are taking an inflated balloon, if we keep our hand upon that, over that, we can feel some vibration in that. It shows air exerts pressure, gas exerts pressure on walls of the container, because gas are in constant random motion due to high kinetic energy. It has more energy to move here and there. These molecules constantly vibrate, move and hit the walls of the container. Okay. Then a wooden table should be called a solid. How do we call the wooden table as a solid? Because as we know, which particles are tightly packed in the wooden table and no intermolecular space because of the light force. When we are applying some light force, it cannot change its shape. So it shows that no intermolecular space between that. Then cannot be compressed by the normal, cannot be compressed. That also shows that is coming under solid. Then it cannot flow from one place to another. A table cannot flow from one place to another. These characteristics are all solid. So wooden table is known as solid, called as solid. Then we can easily move our hand in air, but to do the same through a solid block of wooden, we need a karate expert. As we seen, air molecules, the particles in air will have less force of attraction, so we can easily move our hand in air, but it is not possible for us to move through a solid. For example, brick, only the experts can do. Experts can break. Yeah, solid brick. Okay, next one. Liquids generally have lower density as compared to solids. Liquids generally have lower density as compared to solid, but you must have observed that ice floats in water. Why? In this, ice make a cage-like structure, have lot of vacant in the spaces. Ice cubes will have lot of vacant in the spaces. This makes ice to float on water. Understood? Then for any substance, why does the temperature remain constant during the change of state? What does it mean? Change of state. Solid can changes to liquid, liquid changes to gaseous state when increase in temperature. During the change of state of any matter, heat is supplied to the substance. The molecules of this matter use heat to overcome the force of attraction. Heat to overcome the force of attraction between the particles. At this period time, temperature remain constant. Understood? The molecules will overcome the force of attraction. Heat to overcome that means heat to overcome, in the sense when it is heat, that particles will started to move aside, isn't it? Started to move apart. So the molecules of this matter use heat to overcome the force of attraction between the particles at the period of time. Temperature and remain constant. This extra heat is acquired by molecules in the form of hidden heat called latent heat, to change from one state of matter to the other. So what is the question? For any substance, whatever that is solid, liquid or gas, why does the temperature remain constant during the change of state? If we have to make the ice melts to water, we have to keep outside in the same temperature. That means hidden heat. The matter will absorb the heat. Extra heat is acquired by the molecules in the form of hidden heat. Already that matter will possess some heat, so the extra heat is acquired from the surrounding. The matter will acquire the hidden heat. So this is so that we should maintain constant temperature to make the to change the state of matter. Understood? Then what is the physical state of water at 250 degrees Celsius and 100 degrees Celsius? After 100 degrees, that will be boiling point. 100 degrees Celsius is boiling point of water. So after 100 degrees Celsius, that is 250 degrees, warm water will be in gaseous state, and 100 degrees Celsius, the water will be in the form between liquid and gaseous state. Between these two states, at liquid, Everything will not be as a gaseous form and everything will not be in the liquid form. So 100 degrees will be between liquid as well as gaseous state. Then question 1, to convert the sum of the sums will say, convert the following temperature to the Celsius scale. If it is 293 Kelvin and 470 Kelvin, we should remember this. 0 degrees is 273 Kelvin. To convert into Celsius, we will be minus, subtract 273 Kelvin, and to convert into Kelvin, we will be adding 273. Okay. So, it is 293 Kelvin should be changed to degrees into degrees. That is 293 minus 273 we get 20. So, 20 degrees Celsius. Then 470 Kelvin converts into Celsius. 470 minus 273 is equal to 197 degree Celsius. Then second question, 300 Kelvin and 573 Kelvin. 300 Kelvin minus 273 is 27 degrees Celsius. 573 minus 273 is 300 degree Celsius. Then third one, 25 degrees Celsius converts into Kelvin scale and 373 degrees Celsius converts to Kelvin scale. So we'll be adding 273. 25 plus 273, 298. 373 plus 273, 646. So we should remember 0 degrees Celsius is equal to 273 Kelvin. To convert into Celsius will be subtracting 273 and to convert into Kelvin will be adding 273. Understood? Then suggest a method to liquefy atmospheric gases. How can we liquefy gases? By cooling and applying pressure on them, the gases can be liquefied. Atmospheric gases are taken into a cylinder with the piston, this is known as piston, and fitted into that. By cooling and applying pressure, when the pressure is applying on that means it has more space. When piston is closer to that, less space. So it is known as applying pressure. The space is becoming very less. So in that state, gas become liquefied. Understood? Then give reason for the following observation. Naphthalene balls disappear with time without leaving any solid. It knows naphthalene balls sublime. Sublime in the sense sublimation. Sublime in the sense sublimation. Sublimations in the sense directly changes into vapor. Sublimation in the sense solid directly changes into vapor. So, naphthalene balls changes as a vapor, disappear. Vapor in the sense disappears directly without leaving any solid. Understood? So, these are all the keyword of this answer. Then, we can get the smell of perfume sitting several meters away. As we said, hot food. In the same question, same will be there. Here, perfume contain volatile solvent. Perfume contain volatile solvent. Diffuse faster. Volatile in the sense which can easily evaporate. Volatile. So, that diffuse faster. That will be diffusing faster. So, we can know the smell of perfume from several meters away. Then, give 2 reasons to justify water at room temperature is liquid. Water at room temperature is liquid because its freezing point is 0 degrees Celsius, boiling point is 100 degrees Celsius, room temperature is 29 degrees Celsius. So, if it is on summer day, it will be about 30-32. So, because it's between this 0 degree is freezing point, 100 degree is boiling point. This is room temperature is about 29 degrees Celsius. So, it is in the liquid state. Understood? Then an iron almirah is a solid at room temperature. How is it possible? Because melting point of iron is higher than the room temperature. Any guess what will be the melting point of iron? Melting point of iron is 1530 degrees Celsius. So quite naturally, room temperature we have seen only 29 degrees Celsius. So iron almirah is solid state at room temperature. Okay. Then why is ice at 273 Kelvin more effective in cooling than water at the same temperature? 273 Kelvin in the sense 0 degrees Celsius, isn't it? 0 degrees Celsius is the freezing point of water, isn't it? So when we are taking a ice cube and melted water of ice, that also will be having same temperature. If we keep our hand closer to that, we can feel cold, much colder, which has ice, isn't it? Which is closer to ice, that hand will be feel more colder than the melted water, because it is latent heat of fusion. That means 273 Kelvin will be absorb heat energy from the medium, that is 0 degrees Celsius will absorb heat energy from the medium, from the surrounding, to become water, isn't it? That is, when we are keeping an ice cube out, that will be ready to absorb heat from the surrounding to become water. So this is that feels when it ready to become water, it leaves the coldness. It leaves the coldness. It leaves its temperature to the surroundings. So we feel much cooler near the ice cube, but water does not absorb this extra heat from the medium. Water will be in the room temperature, water will be in the liquid form, so it does not absorb any heat from the external surrounding, so it will not be giving out that coolness will not be much more near water, melted water, but near the ice cubes we feel more coldness. Understood? Well, then what produces more severe burns, boiling water or steam? If we are, both will be in 100 degrees, but boiling water, if you pour boiling water on your hand and steam on your hand, it will give you more burns. Steam at 100 degrees will produce more severe burns, because extra heat is hidden. Extra heat will be in the stream. Okay, so that is known as latent heat. Then boiling water does not have latent heat and it will not cause much burn. Okay, then why does a desert cooler cool better on a hot dry day? That means coolers, nowadays we are converted to ACs now, but coolers we have used. In the cooler we'll be using pouring water that will be surrounded by walls will be surrounded, and this will be sprinkled by water constantly. This water evaporates due to hot dry weather. Evaporation causes cooling inside the air cooler. When we are spreading water, that water will be evaporating in the hot day. So when it's evaporate, it gives us coolness to us. Evaporation causes coolness, cooling of inside air cooler. This cool air is sent in the room by the fan. Understood? That will be, the coolers will be sprinkled by water constantly, that is covered with a cush, that means fiber. Okay, that will be some fiber will be covered, and this constant sprinkle of water will be spread on that. This water will, because of the hot in the outside, this water will on the mat, actually it is in the form of mat. The cooler, this walls of the cooler will be surrounded by the mat. kush mat, and this will be this water sprinkles water will be evaporates because of the hot surrounding. This water will start to evaporate. When the water start to evaporate, it causes cooling, and this cool air is sent to the room, sent in the room by the fan. Okay, so we feel cool air when we are using desert coolers. Then how does the water kept in an earthen pot become cool during summer? Earthen pots, the same philosophy. This is earthen pot is porous. The earthen pot will be having porous with a lot of pores on it. Through this water will be oozing out. Then when the water evaporates, okay, the oozes out, this pores and water gets evaporated, and the pot thereby causing cooling effect. The surrounding of the pot will be cooling. This started to evaporate. The surrounding of the pot will be cooling. So this makes the pot cold, and the water inside the pot cools by this process. Understood? The pot will be having much porous. Through the porous, it will be oozing. Water will be oozes out and make the surrounding cool. This cool water started to evaporate because of the heat in the surrounding. As it evaporates, this pot becomes, surrounding of the pot becomes cooler, and water in the pot becomes cooler. Understood? Why does our palm feel cold when we put some acetone or petrol perfume on our hand? Perfume evaporates when they come into contact with air, petrol, acetone or alcoholic. So when we are applying on our hand, it started to evaporate. So this evaporation causes cooling sensation in our hand. This started as soon as it spreads on our hand. Perfume spread on our hand. It will be evaporating because of the heat in our surrounding. So we feel cold, cooling sensation in our hand. Why are we able to sip hot tea or milk faster from saucer rather than a cup? Saucer in the sense has a larger surface area than a cup. Rate of evaporation is faster with the increasing surface area. Saucer will be larger surface area. Evaporation is faster in the larger surface area. So we can easily drink hot milk from the saucer. Arrange the following substance in increasing order of force of attraction between the particles: water, sugar and oxygen. We may be knowing oxygen is gaseous state, water liquid state, sugar solid state. So force of attraction, increasing force of attraction. Increasing gas will be less attracting force. Then water will be, liquid state will be higher than the higher attraction force of attraction. Then these solids will have much more force of attraction. So oxygen, water and sugar will be the correct order. Then we'll stop till this. The question and answer part of that unit 1, matter in our surroundings. Hope it was useful to you. We'll see with the next lesson in the next session. Thank you.